There we go. Quick introduction about me. My name is Luke. I'm a software engineer at Coinbase. I've been there for 3 years. I've been on the infrastructure team, so that's kind of Devops or SRE, whatever you want to call it. So about 3 years, I've done a lot of things. Just a quick disclaimer, I'm going to talk about vendors here, observability vendors during this talk. But I promise none of it is ill intent. If it comes across like side-eye or like there's problems with vendors, there's no problems with vendors. They just have weaknesses. So I'm going to point out 1 or 2 during the talk. But I promise none of these fine folk were harmed. This is just a list of all the different random vendors that I came up with when I was putting this together. Are people, does anybody here use one of these vendors? Can you yell out some that you use? Kibana, okay, cool. Yeah, a lot. Splunk. Sumo Logic, cool. So, what was that last one? Datadog, all right. Datadog. Let's get in. So, Coinbase. Coinbase is a cryptocurrency, the easiest and most trusted way to buy cryptocurrency online. Does anybody disagree with that? I don't know. It's always a fun topic. This is what Coinbase looks like right now. You can see back in 2017, prices were a little higher, but they're ticking up now. This is my work account. When you go on Coinbase, you buy and sell cryptocurrency. And yeah, I guess that's the intro for Coinbase. But jumping back to before that big spike of exciting prices, Coinbase was actually kind of a relatively small engineering company in terms of volume. This is a chart of leading up to 2017, the amount of back-end request traffic we had to our API servers. So this is anything that wasn't cached in like Cloudflare or static assets. This isn't very much volume, at least for, I guess it wasn't really a brand at that point in the time, but scale wasn't something that was on our mind, which if you're at a company with less than 10 people, scale might not be on your mind either. And you know, we kind of had this red line in mind, or by red line, I mean, if traffic went to that point, we knew we were screwed. And in 2017, the very beginning of 2017, we got screwed. Basically, in the best possible way. People actually started using Coinbase.com. And as a result, our users had a bad experience. That bad experience looks something like this. If you came to Coinbase.com, actually it's animated on the real version, but I couldn't figure out how to get that in the slides. But it's a bad experience. You want to sell cryptocurrency, you want to buy cryptocurrency, you can't. We're down. And the headlines were pretty brutal. We had what I called the peanut gallery. It might have been some of you in the room. I don't know. It's okay. We deserved it. And we had these fun little comments here. This is my favorite one, kind of on theme. Funny thing is that supposedly Coinbase uses AWS, so capacity isn't an issue unless they don't use autoscaling or are too cheap or straight up lazy. Brutal. I used to just scroll through Reddit for hours and just downvote these people. But I wouldn't comment. I didn't want to. I would upvote the people who are like, hey, it's hard to scale a website. And then other people would just be like, yeah, but they have money or whatever. So at that point in time, why were we going down? Right? We were making money. We had talented engineers on the team, but we were going down. We were using a tool called New Relic at the time. Has anybody used New Relic? New Relic's actually pretty sweet. I've learned to say that. I've learned to accept that. And this is what New Relic, it's inverted so it matches the scheme here, but this is what New Relic looks like. It's these cool little time charts. It shows the amount of time we spent in Ruby, the amount of time we spent in MongoDB. And this is what it looked like on a normal day for our backend app. So you can see we're mostly time in Ruby, and then a little bit of sliver in time in the DB. However, when we started breaking during these periods where we'd be down for sometimes hours at a time, we saw a chart like this. And this chart shows that we were spending a bunch of time in Ruby and a bunch of time in MongoDB. But we couldn't understand it. We would just stare at this chart and be like, why is there time in Ruby and MongoDB? We'd look at our MongoDB charts, and they didn't show a slowdown. They showed 30% CPU utilization. So where's the problem? So thinking face. It was during this period where we finally started to ask the hard questions about what was actually happening in our environment. And we did, and we actually came up with a really solid game plan. We started tracking things in Kibana, and this is what happened at the end of that year. So that that massive spike I showed before is intentionally made look very small. That red line is very small because I guess the moral I'm trying to drive home here is we really began to, do I have a little slide for this? No, I don't. Is that we really began to embrace observability in our culture. And that's kind of what I'm here to talk about today, is the different ways that we've engaged with observability at Coinbase and how that allowed us to handle that big spike and how it's allowing us to prepare for other big spikes in the future. So the lesson here is good instrumentation will surface your problems, but bad instrumentation will obscure them and make them more difficult to solve. And it'll make you look stupid on Reddit. So let's take a step back here. What is good instrumentation? Well, I think I could mostly sum it up by saying you just want to know when and why your services break. And I kind of broke it down even further. So really, what good instrumentation is low latency. So I tend to think if it's under a minute, that's pretty good. New Relic, their legacy APM product can be up to 5 minutes before you see what's going on. So you could be making entire changes to your application and not seeing the effect for 5 minutes. Long retention, you want to be able to know what happened potentially a month ago. Theoretically, it's really nice to have. Low granularity, that means you want to be able to zoom in. You want to be able to see at a microsecond level what's actually happening. High cardinality, so that means can you track things like the user ID of a user across the site? Can you track a request ID across a user's activity? For us at Coinbase, we have a special little bullet point on here. This one here, quote unquote secure. Because I don't think just because something is in-house means it's secure, but it tends to help you feel more comfortable with putting users' data into something if it's not being handled by a third-party vendor. So this is something we care a lot about. Finally, you need fast aggregations because you need to be able to look up, if you have event data like Kibana, you need to be able to look up this information for multiple weeks. You need to be able to get actionable information. Or many weeks is even just 12 hours. You need to be able to do that relatively quickly. And finally, an intuitive interface. Other developers in the company need to be able to work with these systems and tools. So who's heard of this before? The 3 pillars of observability? Yeah, I got a couple fans. It's a scam. I'm just kidding. It's fine. It's a really good way to think about things. But I think Datadog invented us to get us to buy all 3 of their products, but I really like it. There's 3 of them: metrics, tracing, and logging. But let's jump through them. So the first one is logging. This is what you traditionally, I put some of the little vendors, some of the ones you yelled out even. You have things like Kibana, Sumo Logic, Splunk. And logging is really, really good for things like audit trails, debug messages, just seeing what's going on in your application. And it's incredible for things like high cardinality information and extreme granularity. Every event that's put through, every log can be down to the microsecond. The cons are that these solutions are not really optimized for storage. And there are slow aggregations. If you want to sum up all the information across all of your events for multiple weeks, you need to check every single event, which can be expensive. I'll get into that more later. Tracing is the entire life cycle of a request or transaction. So tracing is really sweet because it's kind of magical. It's granular timings from the perspective of an application, but it lacks full context because tracing is usually aggregated on an approximation. It's sampled. And there are arguably performance penalties with tracing inside your application on every single request. Finally, there are metrics, which are generally just aggregations stored. Usually what you have is an agent on a box that keeps track of a certain value, like a queue or a gauge, and stores it down aggregated into a service. So Datadog is a really popular example of this, Prometheus. You're getting information on a schedule, right? Every 10 minutes, or every 10 seconds, every second, or something like that. The big issue, of course, with metrics is that it lacks granularity and cardinality. So this can be difficult for deep analysis, at least in my opinion. So if we were to talk about these 3 pillars of observability, what did it look like for Coinbase at that point in time? And really, this is what we looked like. We used Kibana for, glad you like that. We were a Kibana heavy shop. And here's the thing about Kibana or any other log service. You can kind of fill in any of these 3 things with Kibana. So something like Kibana, actually, checking the room again. Who's used Kibana here? Okay, sweet. And Splunk, Sumo Logic, probably about half the room at least has used something like this. Yeah. So yes, technically these are products that are called logging products. But if you put typed entries into Kibana or into Splunk or into Sumo Logic, you can get metric-like data. You can store metrics along with your logs. You can build really expressive charts and dashboards. And you can even do tracing with the tools like Kibana. You can add span IDs, and you can try to build crazy complicated charts. It's totally possible. And possible was enough for us because that was the only product we had. One of our core tenets from a security perspective was that a single strong log pipeline was a really valuable asset. We didn't want to allow random agents on servers in our infrastructure. We wanted to be able to very easily filter any messages coming out for security response, right? If there was an incident and there was, is anybody aware of the Binance hack that happened like a couple weeks ago? Yeah, so Binance got hacked, and Coinbase has never been hacked. Back pat for us. But the Binance got hacked, and when they got hacked, the most important thing at that point in time was figuring out where that hack came from. And if you don't have a strong pipeline where all your events are flowing through, it can be really difficult to get lost in the weeds. So for us, we really invested in this single pipeline, this single Kibana, and God damn it, we can put whatever we want into Kibana. So we did that. Across all of our applications, we emitted metrics. We just print them and then put them through like beats or something similar to that. Have a little enrichment thing, like a little kind of the equivalent of like a log stash, but we just wrote it in-house. Pump it into Elastic Search and use Kibana. This system worked great. And we got some really, really expressive charts. This is one of my favorites. This is the one I use. I tend to be really play favorites with charts. So other people see this and they think it's terrible, but I think it's awesome. It shows me up there that all of our requests are green. That means every single request in our infrastructure is under 200 milliseconds. All the dark greens are under 100 milliseconds. That's sweet. I can tell a lot just looking at this. And I know that each one of those lines on the chart, or each one of those, each request that happened during this period is represented on that chart, every single one. I can zoom into any single request that happened during that period of time. I can see what databases are slow. I can zoom into that specific request, and so on. All this information, I can zoom in as far as I want. It's extremely expressive. Just kind of running through this. The reason why this is valuable is this unlimited cardinality you gain with Kibana. Every single event you put through can have whatever information. It doesn't really matter, right? You can just put anything you want. This is what happens when somebody puts Ethereum into our one of our wallets, right? We have all this information. We know exactly what address. We know what user. We know what instance it happened on. We know, I mean, there's even crazy information here like thread ID. If we want to add more information, we just toss it in. You can do that all day with a log type solution. And the granularity here is also really important. It's down to the millisecond. We can understand on a millisecond level exactly what's happening. We can understand inside an application where things happen, and it's really valuable. So Kibana and logs provided us really with many of the features we wanted. Provided us with low latency, maybe not long retention, but low granularity and high cardinality. And because it was in-house, we felt secure. We knew that our information wasn't being shared across other vendors, and this made us feel really, really good. The problem was aggregations were slow, And Kibana is frankly a little bit of a sharp learning curve. So new developers who came in actually had a lot of trouble with Kibana. That being said, a lot of these features are awesome. Like, why wouldn't you want this? Pay a bunch of money, and these logs, they take up a lot of space, right? That's a lot of information to store one data point. And we piled a bunch of stuff into logs. This is a little picture of Kafka. So we self-managed all this, actually. I should be very clear. I self-managed all this, and it was terrible. And so this is what our cluster looked like. Each one of these lines is an hour worth of data. And each one of these columns is each column is an hour's worth of data, and each row is an instance. So we had piles of these. It got bigger. We had like 40, 60, tons of nodes. There's actually a talk, if you want to really get a laugh, you can look up me talking about Elasticsearch like 2 years ago. And I figured out how to auto-scale it. Don't do that. Most embarrassing. I should just remove that as soon as I get out of here. The point is, we thought this was awesome. We thought this could scale forever. Reality is it didn't. We're putting 200 gigs of logs in per hour or more. And if you kind of do the math here, if you have 40 nodes, and by the way, Elasticsearch, you can't really have more than 64 gigs of memory because of some Java thing that is really stupid. People are aware of this, right? It's stupid. So let's say you have 40 nodes. You're really getting like 32 gigs of RAM, but I'll give it the benefit of the doubt and say 64 gigs of memory. That means you really only have 2.5 terabytes of memory for those 40 nodes, which are pretty big nodes. Usually we did like instance storage in AWS. That means that you can fit 10 to 24 hours of logs in memory. That's not much information. If you're giving access to your developers or other people on your team the information in Kibana, if you wanted to pull up 7 days of information about what happened, think about how much you need to go to disk to pull off all this information to understand what's going on. As our organization scaled, and we went from 50 engineers to now, how many are there, Drew? Call it a couple hundred. People started breaking stuff. People started going in and being like, oh, what if I aggregated all the user data for all the users and made them all a separate line? Guess what happened? Boom, dumpster fire. And here I am trying to figure out why this thing is completely busted up and broken. And guess what? Now there's 60 nodes in this cluster because it's the only way we know how to scale it. Imagine dealing with 60 nodes and the thing's locked up. Don't self-manage your infrastructure. Or your monitoring infrastructure. There were a bunch of things that went wrong with self-managing our own Elasticsearch and Kibana. For one, bad interface for building alerts. There's a product called Shield that Elastic puts out, XPack now. People have used it. I'm not going to say anything publicly about it, but that should tell you a lot. The bad interface for building alerts. Amazon, on the other hand, has a really sweet new product called Open Distro. Give Amazon a little shout out here. That gives free alerting. You don't have to pay for it just to get basic features to a product. But it's still a bad interface for building alerts. There are challenges around long-term retention and management. Just in general, Elasticsearch is not batteries included. Elasticsearch is a tool for search. It's not really designed to be this crazy log pipeline product that you're snapshotting and rolling over indexes. And they've done a lot of work to make it that. But the reality is there's iffy aggregation support. The product generally Elasticsearch doesn't quite scale like it needs to. And that has led to a lot of pain and suffering for us as a team. So the reason we ran into that pain and suffering, this is my favorite. I took a picture of this on a Muni bus. Hiring an engineer to do log admin is like hiring a neurosurgeon to water your plants. I was originally kind of offended by this because I was doing log admin. But at least they're saying neurosurgeon. That's definitely not true either. But it's kind of true in retrospect, looking back on it. And this idea that you're managing all these boxes and da-da-da. The lesson here being, hammers don't work for everything. And we started to use Elasticsearch and Kibana as our source for everything. Just plug, anything can be a log. And it's true. Anything can be a log. Anything you need to track can be an event. You can put it all into Kibana. You can put it all into Splunk. You can put it all into Sumo Logic. But first of all, you're going to start paying a big price penalty. Because guess what? If that's what you're doing, you have to store a lot of metadata along with each log. And we ran into that penalty ourselves. And second of all, you might run into stability concerns if you're trying to manage this all yourself. So this is what we found. So we had our initial list of criteria, and we realized, okay, this has bad alerts. This has bad stability. What are we going to do? We need a magical solution, a knight in shining armor to come in and rescue us. So maybe Kibana was just a bad metrics provider. Maybe Kibana could still be good for everything else. We just need something for metrics. Otherwise, it can be fine for this tracing and logging purpose. So in comes Datadog. Datadog has the best marketing material. Who here's used Datadog? Not as many as Kibana, but still, Datadog has the best marketing material. And I will give Datadog one thing. They're a pretty good product built on what was originally a bad idea. They've made it a lot better. And Datadog, what it does provide is it provides decent latency, about a minute, it's fine. Long retention, you get up to 15 months. Low granularity, nah, not really Datadog's thing. You get like every 10 seconds by default. A lot can happen in 10 seconds, so you get every 10-second granularity by default. You don't get high cardinality. I'll go into that in a minute. And I mean, it's not in-house, so we kind of have light issues with that. But it does have fast aggregation, so you can pull up the whole year, and everything's pre-aggregated. You can understand exactly how your traffic patterns change over the month. You don't have to worry about angering your log admin. It has a really intuitive interface from my perspective. Creating alerts is super easy. You create a dashboard and you click the little alert button on it. And there you go, you have an alert. And finally, Datadog's pretty stable. Although they had a couple outages recently, but I'll let this slide. So yeah, we're obviously compensating for something here, right? Like we're kind of like right on the opposite end of the spectrum when you talk about Datadog versus Kibana. But really, Datadog worked for us. It filled this hole. And suddenly, we have a new hammer. It's Datadog. And just quick lip service, the way we actually managed to feel comfortable letting Datadog into our infrastructure is we did all this crazy gymnastics where we put the Datadog agent on all of our instances in a super locked down configuration. So we actually have a special network bridge. We only pass in certain files. We allow apps to send UDP to Datadog, but Datadog can't talk out except unless it's going to specifically Datadog servers. And that's how we feel comfortable with letting Datadog live inside of our environment. With that being said, Datadog also provides really awesome dashboards. At the very top of this Datadog, this is exciting. A lot of you ask questions. Oh my God, somebody asked about serverless. Cool, that's exciting. We did not, okay, so quickly with AWS Elastic Search, we rolled our own, but I didn't think I'd have time to talk about it today, but we did end up using AWS's Elasticsearch service. We migrated over to that at the end of 2018, and it's been a really big success for us as an organization. We're really big fans of AWS Elasticsearch versus rolling your own. Are these people I work with that are sending these in? Have you tried ElastAlert for elk monitoring? Yes, it was terrible. Are you logging every method call in Kibana? Not quite every method call, but probably per backend API request. I don't know, there's like 15, 20 logs that come through. So not really every method call, not like full tracing or every method call is a span, but a lot of really important information. Okay, I'm gonna save the serverless ones for the end, if I have time. So Datadog, paradise. Datadog is actually really cool. If you're a startup and you're looking for a really good general purpose product, Datadog is really, really awesome. It lets you really easily build dashboards. It lets you build these pre-aggregated alerts. And we really built great dashboards. We built our observability story at Coinbase currently on Datadog. Every major alert that we get to PagerDuty, to Slack, the company runs on Datadog. And that's really good. That being said, there's a couple of issues. The first of all is cardinality. So is anybody aware of the Datadog cardinality concerns? Has anybody worked with this? Anybody gotten bit by this before? You will, if you use Datadog. So the way this works in Datadog is rather than, I showed in Kibana, it's pretty straightforward to understand how logs work, right? They're just basically JSON objects under the hood, right? Key value, key value, key value. Really, like, if we were all in here, put our heads together, we could write a database storage engine to deal with a bunch of JSON objects. Datadog is a little different, though. Datadog doesn't store each individual event. What they do is they take your events at any point in time, and they aggregate them into a 10-second period. So each of these rows here, columns are effectively a different grouping of tags in Datadog. So Datadog is storing per t time period, which are those little, let's see if this works. Yeah, these little things here are the little times, so every 10 seconds you're storing a value for each tag set. The problem is if you want to use tags in Datadog, so let's say you want to keep track of every single route and every single host and all this information, you have to store a different one of these little rows. And this means that you have the potential for an explosion of these rows. What happens frequently is people decide that they want to track each user ID as a tag. Well, Coinbase has, I don't know, publicly, I think we say like 25 plus million users. So that would mean 25 plus million of these rows that show up. So this is what the Datadog story looks like today, right? So taking that same Kibana thing, turning it on its side, we have all these little apps in our environment, and they're writing to Datadog. I see a couple issues with this. First of all, that t-value. Every 10 seconds, we get the new metric values. Datadog lets you configure this down to, I think, a second, or by default, it's 10 seconds. If you're pulling out a CloudWatch, it scrapes every 5 minutes. This is a little bit of a problem, because every 10 seconds is a long time to go between understanding information in your environment. Think about how many things can happen in 10 seconds. Usain Bolt runs 100 meters under 10 seconds. Think about what a computer can do, right? Second major issue, no, this is the same thing. Oh yeah, the idea that you're aggregating every 10 seconds and pushing down. But guess what? These aggregations are happening on each individual host. So how do you get information about percentiles? Do they calculate that ahead of time and somehow do some magic under the hood? No, not really. You just don't really get good percentile values, because you have to aggregate on each host before you send out, right? It's too expensive to send every single one of these little events over the wire. They do that all and then they send it up. Finally, these aggregations are stored by tag. So that's kind of the end of my gripe session about Datadog. But the point is, there are weaknesses to time series data as well. Logs, on one hand, give you this incredible expressiveness, right? But at these major costs. So this is a terrible analogy, but I'm going to try it. So does anybody recognize this picture? Starry Night. The most iconic painting ever. I Googled it, and that's what I got. Now, does anybody know what's happening in that square there, the one I highlighted? $5. Somebody knows that happens at square. Yeah, who said it? I'll give you $5 after. So, but for the purpose of this presentation, that is a gray square, right? We don't know what's going on in that gray square because that happened in our 10-second period. It's definitely dark. It's definitely 40 by 40, right? We have a bunch of really valuable information. But we zoom in, and what are we getting? We're getting the same information. It's not like Kibana where we can zoom in and we have all this high cardinality value, all these specific events. No, we got a dark square. But the reality is, oh, wow, look how expressive, right? All this fun information. Maybe it didn't load as fast on our dial-up modem, but look how awesome it looks. We got all this cool stuff. And yes, the church is in there. And what is, anybody know this? Anybody do like art stuff? Anybody know what's wrong with the church? Come on. I'm not going on until somebody points out what's wrong with the church. Look at the other buildings. There's no light in the church. Van Gogh was upset at the church at this point in time. The Spirit had left the church, is what he said. Or I don't know if he said that, but he said that in his art, right? I read that before I came in here today. I thought it was pretty cool. But if you were using metrics, you might not be able to see that. You might not see the entire picture. You might not see what's actually happening in the church. I don't know, kind of trying that out. So anyway, kind of wrapping up. A lot can happen in 10 seconds. Usain Bolt could run 100, meters. Pre-aggregations also feel kind of dumb. It kind of feels stupid to try to choose ahead of time what you want to aggregate up and put in another place. Because we're limiting the questions we can ask in the future. We're choosing ahead of time what we want to ask in the future. But what if a new problem comes up? We want to ask new questions, but we only have these old metrics that we came up with. So we're running into these weird little issues, right? Where Datadog and these time series stores are kind of solving different problems. Finally, there's no built-in context and discoverability, right? You have all these different metrics, but how do they relate to each other? It's a lot easier in logs to kind of filter around. And finally, the high cardinality is just a major issue. Especially as your organization grows, you can't, I imagine a 10-engineer startup or smaller, you can just go and bop the person on the head sitting next to you and be like, why'd you do that? Can't do that at Coinbase. I wish I could. The lesson is that the grass is not always greener on the side of the observability fence. So whatever product you're using now, it doesn't mean that other products are better. There's no magic product. We've played around with a lot of products, and most of them have what I consider to be an amazing sales pitch, but that doesn't necessarily mean that they're great once you start to use them. So this is what it looks like inside our organization right now. Got Datadog on one side, Kibana on the other. You can see I put my little check marks, right? They're kind of like, you go to Kibana if you want the detailed information. You go to Datadog if you want the big picture. But that's not good. Developers don't want that. Nobody wants to deal with that. People want to just be able to go to one place and get all their information. They don't want this situation. They don't want to have to go across the street. We have 2 different offices now. It's terrible. What if you want to go to a meeting at 1? You got to walk down the street. Nobody wants to do this with their log product either. You don't want to be investigating on this one thing and then have to completely turn around and go to another dashboard and pull up all new things, right? You want all your things in one place. This is what we're going for. So we've had to build these type of things, like these information for engineers. What do I do, right? If you want retention, you go to Datadog. If you want granularity, you go to Kibana. If you want cardinality, you go to Kibana. Do you want aggregations? Guess what? They're going to be slow in Kibana, and you might break it, but not a big deal anymore because we don't manage it. AWS does. And finally, there's no real alerting in Kibana, even though it's recently been added by OpenDistro. So the question I have is, when's this great magical product going to come? Is what you might all be asking. I'm asking it too. I don't know if anybody knows. Put it up here. But there's a lot of alternatives. There's a lot of people selling this solution. The first one I have here is the Datadog Buy Everything plan. And they'll do it all. Datadog will let you use metrics. They'll let you put that same information into traces. They'll let you put your logs in. And we're evaluating this. This is a really potentially cool solution for a lot of the problems I brought up. Just put it all in one place. But guess what? It's still 3 different products, right? They may all be in the same place now, and you may actually be able to jump between the dashboards a little better, and there might be some slicker integrations. But really, overall, what are we winning there, other than paying one vendor all of our money? So the second idea, or alternative, is to double down on events. So anybody familiar with Scuba at Facebook? Can anybody guess who that is in that Scuba picture? No? It's a famous person. Well, one more guess at least. I Googled Scuba, and I was like, oh, that looks like the dorkiest person ever. So I picked it, and I clicked it, and it's Tom Brady, actually. Believe it or not. Yeah. But yeah, that's Facebook doesn't have a Scuba logo, so I made that. So there's a lot of products like Datadog actually has a brand new product called Trace Analytics. Honeycomb, has anybody heard of Honeycomb? Yeah, they've been doing a really good job marketing. These are products that kind of allow you to double down into events. What they say is everything is a trace. And if you are tracing your events and you're using kind of the right system, instead of logs, you basically have traces. Traces are how you understand information. Traces kind of provide you, we sample your information, we get you metrics, and we allow you to search across those traces. That's something we're very interested in. But you know what, really? Kibana holds a special place in my heart. And it would be really nice if Kibana really figured this out, if they found a new backend. So kind of in closing, I don't think there's a perfect solution yet. There's a lot of things being marketed. There's a lot of cool new ideas in the future. But we're currently exploring them. And I'm really interested to talk to you all after and hear kind of your experiences and how, what potential fun things we could do over here at Coinbase. So that's the end of the official information I have. So thanks everybody for listening. And if you want to start putting things on the Slido, I can start answering them. Oh yeah, so let's start with serverless. I actually had a whole little appendix I was going to put in here, but I was getting pressure. You said I had too many slides. I didn't know I'd come in like time early. Okay, cool. So how many people here are using serverless in some way? And how many of those are Lambda? All of them. All of them? Anybody using something other than Lambda? And that would call it serverless? You wouldn't want to get caught doing that here. You might get kicked out, right? You can talk to me after. So Lambda's really interesting from an observability perspective. How many people here have used observability products other than AWS's with Lambda? Does anybody? So they make it really hard to do that. Because what's the thing about Lambda? Lambdas are ephemeral. Yeah, they stick around for a little bit, but they're eventually garbage collected, right? You don't know how long your Lambda is going to be garbage collected. It can be 15 minutes. Sometimes they last up to 45 minutes. So let's say you have an event, like even a Datadog metric, right? If you're on a host, Datadog puts a little agent on there. Oh, you know what's sweet? I actually just have my work laptop here, so I can go to these slides. Yeah, that's me. Lambda doesn't like agents, right? So Lambda doesn't like agents. And the reason why, so even on a regular server, you have a Datadog agent, or a collectd agent, or beats, or whatever. And what do these agents do? They flush, right? They get a bunch of messages, they flush. They don't write every single event immediately. Some of them might have a really low flush period, but your app certainly doesn't have to block on observability. If your app wants to say blank happened, they write out to the agent, usually with UDP, right? Very low latency. And that's really useful. But Lambda, you can't just run a sidecar agent. I mean, technically, you kind of can. But even if you did, what's the big issue? What happens when your function finishes executing? It's frozen, right? So what if you're buffering up events? What happens? Oh, yeah, sorry. And I was going to point out, the other option would be to go into your VPC, which is where all the fun things happen. You have all your cool tools, but obviously we all know, we're all AWS people. VPCs are dirty in AWS land, right? If you use a VPC, you're doing it wrong. You should all be in the happy, lovely, non-VPC, Amazon locked-in vendor environment, right? We're all happy here. But who said that?
That's like the opposite.
For what?
Like, if you deploy anything to a non-VPC anywhere, your networking doesn't work as well. You can't access any of your other things.
I don't know. If you're using Lambda, there's very little reason to use the VPC for a greenfield app. DynamoDB, baby. No VPCs, no problems, no scaling worries. It goes forever. I mean, I'll talk to you after. I'm happy to be wrong here. You have to have, most people have real servers. Most people have real databases. And those live in VPCs. Lambdas don't live in VPCs. They don't. They can have ENIs attached to them. And having an ENI attached to an ELB also takes 10 seconds, which is how long it takes for Usain Bolt to run 100 meters. So do you really want to wait around for a cold start of a Lambda? No, just forget the VPC. Anyway, that's not the point. The point is that what are you going to do? Are you going to send your events out directly to the HTTP APIs of these services? Are you going to wait every time you have an event for exactly however long an HTTP request takes? No. So what you're going to do is you're going to try to buffer them up. So you have a Lambda, you have a flush size, you send them out after like, let's say 10 or 100 events. The problem is, of course, that Lambda gets garbage collected. So while your Lambda is frozen, has a bunch of these events buffered up between requests, Amazon decides, oh, we're taking down this Lambda. I don't know, in their infinite wisdom. And they cut it down. What happens to all your events that were buffered up to be sent out? Trash can. They're gone. So Lambda doesn't like agents. Lambda doesn't like external services. So what do all these people do? Well, okay, yeah, you don't want to do this, right? You have to write out to CloudWatch. You have to write these little async logs to CloudWatch, and then you have another little Lambda that listens to CloudWatch, processes these, sends them off to all your different services. With tracing, if you want to use something like Datadog, you have to write out to X-Ray, and then Datadog tries to suck it in and figure everything out. Anyway, that is the question about how can you do this with a serverless app. It kind of sucks. I mean, all these vendors are scrambling, right? We talked to Datadog a lot about this, and they're coming up with solutions for this. But it feels weird, right? You have to put every event through in a log, and then it turns into a metric. Kind of weird. No, we're not talking about that. I guess the moral here is that everything is an event anyway. So if Lambda is doing anything, it's saying use events. Don't use like aggregated metrics. All right, let's move through here. Cool. Can you please elaborate on the discussion that takes place on security when deciding on in-house versus buy? What's the general framework from a technical security side on building in-house versus buy and having an on-site secure deployment? So I would take issue with calling an on-site deployment secure. In order to have something on-site, you need to have experts in the house for that tool. Otherwise, you're probably going to be running it, mediocrely. How many of you have run like that random service on a box and it works and then it breaks, or it's logging out somewhere weird? The process basically looks like, is this critical? Is true customer data going through this? Is there PII? Is there any chance for private keys to leak to this? Right? So those are things like a logging framework is a classic, right? Like accidentally leaking data to it. That is a solution where we'd love to have it in-house, because we really don't want those keys to go to, theoretically, some third-party service. But we're cognizant of the fact that you really can't in-house run a service perfectly. It's really, really difficult unless you have experts. When you get to the bigger sizes, Coinbase is still in this awkward stage where we're these couple hundred engineers. We don't have time to spin up a 5-person Elasticsearch team. We don't have the engineering resources for that. That's what AWS is for. If you're Facebook, you want to go send like 5 PhDs to go create Scuba and then hire a bunch of sysadmins to manage it for the rest of the time, go ahead and do it. No problem. You have specialized solutions. You're big. Go do it. For us, we have to kind of balance that. And our security team does a great job when they evaluate vendors. Most vendors are surprisingly good about the way that they engage us, the type of comfort they give us when we're using their products. We use a lot of third-party products because it's a SaaS world. Not everything can be on-prem. We have a terrible experience with most on-prem things. It's terrible. Anybody heard of Replicated? Yeah. Anybody had a good experience with Replicated? You have? Wow, okay, cool. Talk later. I haven't used Replicated much, but my general experience has been everybody who has used Replicated has had a really bad time, especially internally. So, yeah. It's a cool product, I guess. All right, Yeah. DevOps culture at Coinbase. So DevOps at Coinbase is interesting. We have always, something interesting about Coinbase, you can't SSH into servers in production. So think about how that changes the way you have to think about being a DevOps engineer. Think about how much harder that made it to manage Elasticsearch when you don't really have SSH as an option. We blue-green deploy everything, and we don't SSH into the services that exist in our infrastructure. We have break glass procedures for getting on a box, but guess what? Everybody gets involved. You have to go to an incident afterward, da-da-da. Nobody wants to do that. So what does that mean? It means we do write a lot of code. It means we do test the things we do frequently. We have a project called the 30-day project. No server lives in our infrastructure for more than 30 days. What does that mean? It means everything needs to be deployable on demand with a button. That's really, really hard. And that means we have to write a lot of automation code for how we deploy services, especially those stupid replicated ones, which gets a lot harder. Yeah, I don't know. I don't even know what I got. That question got removed, but I don't really know where else to go with the DevOps thing. So if you want to post another one, I'll go deeper on that. Grafana. Somebody asked a Grafana question. Why don't we just use Grafana? A couple reasons. So mainly, we used to use Prometheus and Grafana for a short period of time for all of our metrics and logs. There were a couple reasons we didn't like Grafana. We didn't like the alerting interface, primarily. And we were not a very huge fan of just like configuring it and like multi-users. Like, so once you have a certain number of engineers, like you don't want people like touching weird stuff. And it was really hard to do permissions. Admittedly, I know Grafana's come a long way. And I also know that we probably kind of didn't give it the full run through. So Grafana is an interesting thing for the future. But my understanding with Grafana is you mostly, like under the hood, you're mostly using, oh no, don't do that. You're mostly using like managed solutions in-house. We had a lot of trouble managing Prometheus. Or it was really difficult with the blue-green deploy process. They didn't add remote storage backends until well after we decided on Datadog. And even the remote storage backends are primarily InfluxDB. So anytime we have to manage, we're really anti-managing databases ourselves. We're not really DBAs. Amazon does that. So when we have to use a tool like InfluxDB for managing all of the backend for Prometheus, that means we have to write deploy scripts for how this all works. We've had bad experiences with that. But nothing against Grafana, really. So yeah, there's a question about more elaboration on what we use for tracing. Right now we use Datadog APN for tracing. We also use X-Ray now, because we're really moving to serverless pretty heavy across the organization. And X-Ray is the best for, because basically Amazon puts an X-Ray agent on every box. Every like serverless mega box or whatever they are. And there's an X-ray agent, so we use that. What we're looking to do though, is we're looking to move to something like, what did this person say? Evaluated tools like Jaeger or Zipkin, have not. But we're looking at tools like OpenTrace, like how can we work with Amazon and Datadog to have kind of sane unified events that can work whether serverless or not, and how do these things communicate? That's one of the big things we're working on right now is how can we unify this stuff? If one Lambda talks to another through an API gateway, X-Ray is really good at that, but what if one Lambda is talking to a regular ELB and it has like Datadog on it? How do they communicate? That's like an open question for us. What if your only option for log extraction is syslog? No option, okay, this is like a puzzle question. What if your only option for log extraction is syslog? No option to install an agent, but you can send syslog anywhere you want. So, anywhere I want. Syslog, you can just forward UDP, right? You just fire it off somewhere else? Why would, who asked this question? Monitoring Heroku. Interesting. So, and you can just send it to fire off UDP packets anywhere, right? Yeah. It's interesting. I mean, I would probably just run a separate service that listened on. I mean, so is that because you on Heroku? I'm actually not very familiar with Heroku. With Heroku, you just run a separate. Can you run sidecars? No, so you would just run, in theory, like a Datadog agent that's listening for logs on TCP, syslog forward TCP to that, and another like dyno or whatever. Yeah. Interesting. I wonder how Datadog would handle that, though. Datadog probably has a whole page on that. I would link into Datadog. I just like, because these big companies like Datadog, they do a really good job at like figuring out how to sell you their product no matter who you are or what you're using. They'll have a whole page that some random engineer wrote up and made it sound really easy, even though it's just like toothpicks and rubber bands. That's how it all works. Alerting for build versus buy. So, sorry, just to be clear, we do use PagerDuty for everything. Everything, all of our alerting and all that goes through PagerDuty. I couldn't imagine making that ourselves. Alerting is the worst part of monitoring or managing yourself. Because if alerts are critical, so when I joined Coinbase, we used to have little minor issues here and there, and it wasn't a huge deal because nobody really used it, and the people who did would just come back tomorrow. But that changed. People expect better today. We're a real service now, and we're competing with other real services. If we're down, our competitor just got a customer. Not good. So we want to know when things break. And ElastAlert was really bad at that because, partially because Elasticsearch was down a lot, or it would fall behind because Elasticsearch would get slow because these big aggregations people would run, and the consumers would be writing to Elasticsearch. Elasticsearch would be slow, so logs would fall behind. If logs are behind 5 minutes on an instance, and we don't have this anymore at Coinbase, but we used to have this tool called the hedger that would kind of like, as people are buying and selling on Coinbase, we rectify it to our exchange. And if that falls behind, we're in a potential issue with what if the price shoots up and we're trading all these Bitcoins at lower prices? We need to be alerted when bad things happen. And if we aren't being alerted, we're potential major risk. It could be a security risk. It's not just a matter of, the site's down, time to put my sweatpants on and walk to the living room. It's not that. It's, this is important. Customers rely on us. Not customers just rely on us. Like, my career rests on the company not going under because alerting broke. It's like, trust another company to do that. Okay. How am I doing? Okay. Did we give Instana a look? No. That sounds great. Wait, do I get a copy of these questions later? Yeah, okay, cool. I want one. Because is it like who did this Instana question? Is it like a Grafana thing?
You deploy your agents into somewhat like Datadog, but German small company, great stuff, especially with Microsoft.
And what's the backend for that? Or like you have an agent, what's it sending to?
You can either host it yourself or you buy something from them.
But you just run it and it just does all the remote storage and all that. Interesting. Haven't looked into it, but that sounds cool. Okay, what would I do differently if I were to start from scratch and weren't heavily invested into Datadog and Kibana? Good question. So I've heard really good things about tools like Honeycomb. I've heard really good things about tools like LateStep, and I play around with them. The biggest issue is that some tools just don't have a story for serverless, and it's kind of a bummer. Like LateStep, if you search for, I did this a week ago. I bet they put one up in the last week, but I searched for LateStep and Lambda. There's not something for me to do, and that's kind of a bummer. But I'd probably go events only. And by events only, I mean I wouldn't probably do any aggregations. I'd try to do something that's completely in memory, and I would not worry as much about retention. So I'd probably worry about a 30-day retention and try to keep every event that we emit in memory and pay for that memory. That would be pretty sweet. If we could do that with Kibana, we'd probably still be using Kibana for a lot more, except Kibana just basically falls apart at the seams, or it did for us. So. How many days will it take to set up your 100% dream observability tool comes along tomorrow? Okay, if we wanted to switch to a dream observability tool, how long would it take? If it's a dream tool, I'm talking beautiful and just solves all these little checkboxes, Well, we got to wait for the security review. So that's going to be at least a month. But as soon as that's over, we're live. You have to think the hardest part at a company like Coinbase, in terms of timing, is getting, if you have a vendor that you're reviewing, or even a new product, right? Even if it's a hosted product, we still can't just let this thing hold all of our data unless we review it. So if it were 100% dream, I'm sure we'd stop everything and move over. But you know it's not going to happen. That's not going to happen. Whoever asked that question, you know it's not going to happen. Somebody's going to come out with a really good solution. It's going to be half-baked, and we're going to be like, shoot, we'll move to that when they're ready. And it'll take another 6 months. We'll start toying around with it. We'll slowly build up to using it. Okay, so I think I only have time for one more. Oh, I'll do this quick one. What do we use to automate infrastructure? We blue-green deploy. We actually use a homegrown thing. This blue-green deploy new autoscale group has a bunch of instances in it. Each instance is kind of runs Docker containers. And we have a light Docker Compose style thing for each container. But autoscale group's basically behind load balancers. So for the final question, what happened with the traffic increase? This is my favorite question to answer. So glad somebody asked it. I still think the people who came from my company are feeding me all these fun ones. So when the traffic went up, there were entire days where we sat in a room and we just stared at the screen like, whoa, this is bad. The New York Times wrote an article at one point, and it was like, Exchange Coinbase down. And I remember seeing that and being like, oh my goodness, this is the New York Times, and they care about us, and it's bad news. This is terrible. We've been excited for this the whole time, and now we're down. These Reddit comments and all that. And to be honest, like I kind of pointed out, we had monitoring that wasn't telling us anything. So you know what we did? We threw everything at the wall to see what would stick. And some of that was really dumb. It ended up being that our databases were slow. Shocker. We were using MongoDB, and MongoDB, even though it was only at 30% CPU utilization, was still slowing down enough to slow down our workers enough. To basically overflow our queues and just start throwing 500s. We're just slow enough that it wouldn't work. Oh my God. Sorry, that's so embarrassing. Screensavers. But what we ended up doing during that period, because we had the bad observability, is we were forced to do things. I remember somebody made a kernel change, and we're like, this is the Linux kernel's fault that this is happening. So we went in, we just started changing all these weird concurrency settings and thinking, maybe this will solve it. And we'd change it, we'd redeploy, and we'd watch, and it would just still be down. It's like, oh man, bummer. And it just really drives home this point that we didn't have the observability we needed. The second we added Kibana events on every single DB query that took longer than 5 milliseconds, that's what we did. We added a Kibana event on every single DB query that took longer than a threshold. And we charted it. We could see exactly what DB was slow. We found a way to remediate it by lowering queries, scaling up, or sharding the DB, a bunch of different techniques. And the good observability solved our problems. And I know that I sound like I'm just saying this because it's observability talk, but that's seriously the case. It was good observability solved our problems. It made our lives easier. So yeah, I think I'm officially out of time. Are they going to drag me off stage? So one last question. We do not use Kibana or Datadog for continuous delivery gates. Continuous delivery just happens. But maybe in the future we'll start to do that. Anyway, that's all I have, everybody. Thank you so much for coming out. It was a lot of fun. I'll be hanging out.